Sometimes we work with consecutive even integers. Consecutive even integers. Well, 8 is an even integer, 200 is an even integer, -6 is an even integer. Let me use as my example to start with 6. The next even integer after 6 is 8, followed by 10, and then 12, and so on. And so 6, 8, 10, 12, ... would be an example of consecutive even integers. To write these as formulas, we'll use x as our first one, as usual. Now, how do we get from 6 to 8? This time we have to add 2. And so my next even integer would be x plus 2. To get to the next one, from 8 to 10, I add 2 again. Add 2 to x plus 2, and I get x plus 4. And then x plus 6, and so on and so on. And so the formulas that I would use to represent consecutive even integers would be x for the first one, and then x plus 2, x plus 4, x plus 6, and so on. Well, if integers are not even, they're odd, and so let's take a look at the formulas for consecutive odd integers. Odd numbers. Well, 9 is an odd number, -3 is an odd number, 251 is an odd number. Let's use 5 as a start. 5, then 7, 9, 11, 13, 15, and so on and so on. For formulas, we'll start with x, of course. Then how do we get to the next odd integer? What do you add to 5 to get to 7? Well, you add 2. And so x plus 2 is the next one. And then to get from 7 to 9, we add 2 again. Add 2 again, we get x plus 4. Add 2 again, we get x plus 6, and so on and so on. And so the formulas for consecutive odd integers will be x, x plus 2, x plus 4, x plus 6, and so on. Now you notice something strange. The formulas for consecutive odd integers and the formulas for consecutive even integers are identical. They are exactly the same. How can that be? Notice that it's all in a matter of where we begin. If we begin with an odd number, like, for instance, 23, 23 plus 2 would be 25. 23 plus 4 would be 27. So beginning with 23, we would then get 25, 27, 29, and so on. We would have odd numbers. Beginning with an odd number, adding 2, 4, 6, and so on will keep us with odd numbers. On the other hand, if we begin with an even number, like 16, adding 2 will get us to another even number. Adding 4 will get us to another even number. So we'd have 16. 16 plus 2 is 18. 16 plus 4 is 20. 16 plus 6 is 22. 16, 18, 20, 22, and so on. And so it's not difficult to catch on to the fact that it's just a matter of where we start that gets us either even integers or odd integers, even though the formulas are identical. Let's look at a problem that asks us to find some consecutive integers. I'm going to uncover this line by line so we don't get lost. Our first example, find 3 consecutive odd integers. Find 3 consecutive odd integers such that 3 times the middle integer, such that 3 times the middle integer is 13 more than the sum of the first and third. 13 more than the sum of the first and third. Find 3 consecutive odd integers such that 3 times the middle integer is 13 more than the sum of the first and third. Now this time, notice that we are to find 3 integers. That means we're going to get 3 answers. We know that they are called the middle, the first, and the third. So let's call them the first, the second, and the third. For the first integer, we'll use our usual x. The first integer will be called simply x. We're told that these are odd integers, consecutive odd integers. And so we remember that our formulas for odd integers are x, and then the next one is x plus 2, and then x plus 4, and so on. And so our first integer will be x, the second will be x plus 2, and the third will be x plus 4. Now we'll go back to the words and see how this all fits together. Locate the word is for the equals. Here it is. Is the equals. Before is, we have 3 times the middle integer. 3 times the middle integer. After is, we have 13 more than the sum of the first and third. 3 times the middle integer. 13 more than the sum of the first and third. I'm going to write what we call a model that gives us something of a mixture of the mathematical statement and the English, so that we can keep straight what's going on.